Hey everybody, it's Lynette Schaefer, and in this lighting controls basics course number 1, we're going to be going over what you can do with lighting and also wiring a 101. So of course, we all know you can turn lights on and off. That's pretty easy. We can increase or decrease the intensity. We can change the CCT, of course. And last, we can also change the actual color of the light source as well. Now, when we start to deep dive into each one of these, we have the old-fashioned control, which is just turning the light source on and off. But we can also, of course, increase or decrease the intensity, which is basically the brightness of the light, by dimming them up or down. Now, as we look at dimming an incandescent lamp versus dimming an LED lamp, they are very different when it comes to the characteristics. So what I mean by this is incandescent lamps naturally get warmer as they dim, moving from around 2700 K down to about 2200. However, when you dim an LED light source, they actually stay at their same color. So if the LED is 4000 K and you dim it, it's going to stay at 4000 Kelvin. Now, a number of years ago, some manufacturers came out with this technology called dim to warm. And basically what it does is it replicates the appearance of an incandescent lamp. Dim to warm lamps or fixtures consist of cold and warm LED diodes. And when you decrease the intensity of the light source, the internal control circuit dims the cold LEDs first, then pushes more current to the warm LEDs, allowing you to have a more smooth variation from cold to warm. Usually this ranges from about 3000 K to about 2200 K. Now, as a side note, when we say 2200 K or 2700 or 3000, we are talking about CCT, which stands for correlated color temperature. This, of course, that you see here on the screen on the far right-hand side, this is the chromaticity diagram, and the black line kind of towards this little bit under the middle part of it. That black line that you see here is actually called a black body curve. And that's basically where you're going to find the different CCTs ranging from 2200 on the far right, or about 2000, all the way to the far right, which is about 10,000 K, which again would be to the very far left. Now, changing the CCT is another thing we can do with lighting now, especially with LEDs. You can see here, the reason that people would want to change the CCT is because it can totally change the ambiance of the space. Now, the industry typically refers to being able to change the CCT within the fixture or within the lamp itself. They basically refer to this as tunable white, which is much, much different than color changing. Specifically, when we look at the chromaticity diagram, there are many other colors that fall outside the black line. And that means that you can change the colors of the light source. Yes, you can change the CCT, but it's different because those fall on that black body line that we talked about. But these other various colors can be produced with the right LEDs. Now, RGB, red, green, blue, are the 3 primary colors of light. But there are many other colors that can be produced, like yellow and pink, for example. All these colors on the chromaticity diagram produce different colors by combining red, green, and blue LEDs into the light source and then controlling the amount of current going to each diode, as I mentioned earlier. Now, in some cases, it's really nice to be able to control the color of the light, especially to highlight the outside of the buildings, or maybe coves or bridges, maybe in a hospitality setting like a restaurant or hotels, and concerts and theatrical settings. And sometimes even in our own homes, it's kind of cool to be able to change the color as well. So as we all know, when it comes to controlling lights, you have options, especially with LEDs now. You just have to decide what is it that you want them to do. Do you just want the light fixtures to turn on and off? If you want to increase or decrease the intensity, you're going to have some sort of dimming compatibility or inability to do that, or ability to do that. Maybe you want to change the CCT, or maybe you want to change the color. Now, for many years, most people were okay with just using a simple light switch or dimmers to control the lights. But nowadays, it's time to move over that old light switch and throw it out, because energy codes and people have evolved, and the need to have automatic control is becoming much more common, whether that's a wireless sensor or a wireless switch. So then the question is well, how do you make it lighting automatic? Well, first we need to back up a little bit and understand some of the basic principles when it comes to lighting. And a pretty important principle is understanding wiring. So generally speaking, a basic wiring consists of either 2 or 3 wires. And these wires come out of your electrical panel. They run usually up through the walls, usually with a switch, and then that continues up to up through the wall to the light source. Now, this is usually referred to as a circuit. So when someone presses the button or flips the switch, the lights either turn on or they turn off. So that circuit is either, turned on or live when you turn on the fixture, or when you shut the fixture off, it shuts off the circuit and there's no more power running through that, those wires. Now, in the case of dimming, when someone increases or decreases the intensity using a dimmer switch, the switch increases or decreases the voltage to the light fixtures through these same power wires, which results in the light source to either increase or decrease in intensity. This type of dimming is known as triac dimming and is found in most residential applications. So in this case, you can see here, you're dimming the fixture now. It's going through the exact same power lines and you don't need any extra wires. But now let's say instead you want to dim the fixtures using 0 to 10 volts. Now this is found commonly in commercial and maybe some industrial applications that need dimming, but definitely commercial applications. And, you can see here, you still have your everyday, line voltage wires, your everyday power to those fixtures. That doesn't change. But now with 0 to 10 volt dimming, you actually have 2 extra wires. Those wires are usually violet and pink. They're usually fairly thin in nature. And now when the dimmer slides up and down, there is a low voltage signal that actually runs through those low voltage wires, which then increases or decreases the light output. It no longer uses the line voltage wires to send the signal to the fixtures. So instead, it's using those low voltage wires instead. So whenever you're using 0 to 10 volt controls, or you have maybe an LED that has 0 to 10 volt driver, you need to make sure that you use 0 to 10 volt control wires and that the fixtures are suitable for 0 to 10 volt dimming. So what about wireless controls? Well, when it comes to wireless dimming, or other wireless control strategies, it doesn't mean there's no wires. In these cases, you still have to have power to the fixtures, but now the signal travels wirelessly using a communication protocol, whether that's Wi-Fi or Zigbee or maybe Bluetooth. And the control device, whether that's a switch, an iPad, an Android device, or whatever, it no longer needs to be wired into the circuit like these other previous examples I just provided. In all these other cases, the switch actually needs to be wired into the circuit, but with a wireless control, you don't need to worry about that. You actually don't have that wired into the circuit at all, because it's not controlling the circuit, it's controlling a group of fixtures that are programmed to speak to one another via a wireless signal. Now, speaking of circuits, a circuit is a closed path through which electric current flows or may flow. There are series circuits and there are parallel circuits. Now, if a switch is added to a series circuit, which you see on the left-hand side of my screen, then it controls everything on that circuit. So if you've got 3 fixtures like you have in this example, that switch is going to operate the entire 3 fixtures, the entire circuit. If it's a parallel circuit, then each switch is in series with the fixtures, and each switch lamp combination are in parallel with one another or each other. Now, this kind of gets a little bit interesting. Back in the day, it was very important to understand circuits, and it's very important from a controls perspective. But nowadays, since many controls are wireless and more people are moving to wireless solution, circuits aren't as important, because with wireless controls, the signal is sent wirelessly. So fixtures now have their own basically fixture controller that receives the signal and it tells the fixture what to do, versus sending a signal through wires. So anytime you're doing maybe triac dimming, or you're doing just an on-off switch, or even 0 to 10 volt dimming, you do have to worry about circuits. But with wireless type of situations, you really don't need to worry about that as much as you used to. Now, there's also something called lighting load, which is the amount of power a light fixture draws. The calculation for lighting load is basically watts equals volts times amps. And a circuit has an amp rating that it cannot exceed. So most circuits, it just depends on your panel, what can the circuit hold? It has an amp rating, and that amp rating cannot be exceeded. This usually is something that the contractor needs to worry about, not so much us selling the product. Now, dimmers and switches and other control devices can handle only so many system watts, just like people can only lift so much weight. So when you're dealing with wired circuits, it's really important to ensure you don't exceed the amp rating. And like I said, this is really kind of nice because it's up to the installer to determine in most cases. So with wiring, we all know you have basic or standard wiring, and it provides power to the light source. No matter which way you look at it, you need to have power going out to your fixtures. You need to provide power to the light source. As a side note too, power to the light source can be accomplished through Ethernet cables. This is something kind of a little bit new, probably got introduced maybe about 7 years ago. But with power over Ethernet, it can be fairly expensive. That is still something that hasn't come down much in price. But power over Ethernet is nice because it doesn't use the 2 or 3 power wires or the typical, standard voltage wires that I was talking about previously. Instead, those power wires are actually replaced with Ethernet cables. Basic wiring or voltage wiring can be used to dim light sources, and of course the signal travels through these wires. So Ethernet is something slightly different. Basic wiring, as I mentioned, you can dim the light source if you want, and the signal travels through those wires. When it comes to 0 to 10 volt wiring, this is used in conjunction with basic wiring, and it is used to send a signal via low voltage control wires. That signal will tell the light source to either increase or decrease in intensity. Or like with 0 to 10 volt, you can actually have it do other things besides just increase and decrease in intensity. But either way, you need those control wires to tell the light source what to do. In my example here, I'm basically just telling it to dim down in the previous slides that I showed you. Now with 0 to 10 volt dimming, as we talked about, there are 2 additional wires that are required. And of course, all the fixtures connected to these other 2 wires, these low voltage control wires, they're all going to perform the same task. So there's really no individual fixture control from that perspective. So the last one in summary is wireless. And the reason I put this sort of off to the side is because with basic wiring and 0 to 10 volt wiring, the signal is sent through wires, while in a wireless situation, the signal is sent wirelessly. And that means the communication to the light source is all done wirelessly. But of course, you still need to have power to the fixtures. You can't get away from that. So that concludes this particular session of Controls Basics segment number 1. I want to thank you. And if you have any questions, feel free to reach out to me at lynette.schaefer@eiko.com.